Hi class, my name is Berlin Needham and my partner Lizette and I are going to teach you about the leading thinkers of the scientific revolution. I'm going to share my screen with you guys so you are able to see our PowerPoint that we created. Hang on one moment. All right, here we go. So two of the most important leading thinkers of the scientific revolution were Nicholas Copernicus and Galileo Galilei, which we are going to talk about today. So first we need to talk about what was the scientific revolution? Well, it occurred towards the end of the Renaissance period in Europe during the 17th and 18th centuries, and human knowledge about the universe began to evolve. Prior to the scientific revolution, people modeled their views of the world based on their religious beliefs and classical Greek and Roman methods. However, scientists during this time started realizing the inadequacies of these methods and began devising new methods of their own. However, this was easier said than done because the Catholic Church was the dominant authority at this time, and many of the new scientific methods that were emerging were against the Catholic Church. Fortunately, the fear of backlash did not stop these scientists, and they continued to devise these new methods based on direct observation and mathematical reasoning. And the reason the scientific revolution is so important is because it led to modern science methods that we still use today, and it also paved the way for the age of enlightenment. So as I discussed before, two of the leading thinkers of the scientific revolution that we're going to talk about today are Nicholas Copernicus and Galileo Galilei. So Nicholas Copernicus was born on February 19th, 1473 in Thorn, Prussia, which is now known as Toruń, Poland. He was an extremely well-educated man as he studied a variety of subjects at several different universities. The subjects he studied included philosophy, law, medicine, astronomy, and even Greek. So he eventually received his doctorate in canon law in 1503. Even though he studied a wide variety of subjects, he had an extreme passion for astronomy. And we have to remember that Copernicus lived in a time before the telescope was invented. So astronomers during this time had to rely only on observations made with the naked eye. So while Copernicus did make some observations of the night sky, he mainly relied on studying astronomy through mathematical calculations and geometry. Prior to Copernicus, the widely accepted model of the universe at this time was the Ptolemaic theory. And this theory stated that the Earth was motionless and the center of the universe, so geocentric, and the Earth was surrounded by 9 spheres that revolved around it. And each sphere contained one of the heavenly bodies. So the first 7 spheres contained the Sun, the Moon, Mercury, Venus, Mars, Jupiter, and Saturn. And the 8th sphere held the stars. And the 9th sphere was empty, but it provided the spin that kept all celestial bodies, so all the planets, the stars, the sun, it kept everything moving. And then beyond the 9th sphere was heaven, so the realm of God. Another important thing to know about the Ptolemaic theory, and just the thinking about the universe at this time, was that space was thought to contain perfect heavenly bodies that moved in perfect circles around Earth. And the geocentric model really upheld Christian beliefs. So here's a photo of the Ptolemaic model. As you can see, the Earth is in the center, the geocentric model, and here are the 9 spheres. So then we need to move into the development of the heliocentric model. So astronomers during this time began to realize the discrepancy of the geocentric model, and Copernicus was included in these astronomers. The most obvious discrepancy that they seek to explain was the irregular movement of the planets that revolve Earth. So Copernicus wondered if the heavenly bodies in space supposedly revolve around Earth in perfect concentric circles, then why could sometimes the planets be seen slowing down or stopping in their courses, or even sometimes changing courses altogether. So Copernicus declared that the Ptolemaic model provided an irrational picture of the universe, and he set out to create a model that would more accurately depict the universe. This leads us into Copernicus' first work, the Commentariolus. So he produced the Commentariolus in 1514, and this was after several years of calculating and reconfiguring and really trying to figure out what was going on beyond Earth. So this was an initial sketch of his new cosmological ideas about the arrangement of about the universe. And in this, Copernicus suggested the need to reject the Ptolemaic theory and provided new theories that provided a better explanation for the movement of the planets. And it is important to note that Copernicus never actually published the Commentariolus, but he did work really hard and continued to dedicate his time to astronomy and eventually developed a later work, which I will talk about later on. So in the Commentariolus, the Copernicus' new theories that he introduced were that the sun is the center of the universe, therefore heliocentric, and all celestial bodies, including Earth, revolve around the sun. Additionally, the apparent movement of the sun and the retrograde motion of the planets was due to the motion of the Earth. And the Earth rotates daily on its axis, and the Earth revolves around the sun annually. So he had several different ideas that were completely new during this time. So here is a picture of the Copernican model, and as you can see, the sun is in the center, heliocentric, and here are the planets revolving around the sun now instead of the Earth. So, as I mentioned before, Copernicus did end up developing a more detailed version of his theories. However, he was very hesitant to officially publish his new heliocentric model because he knew he would face scrutiny from many people, including the Catholic Church. So it actually wasn't until he was on his deathbed that he received the first copy of the publication of On the Revolutions of the Heavenly Spheres. And in a political pursuit to try to limit the backlash received from the Catholic Church, he actually added a dedication in this book to Pope Paul III. So, On the Revolutions consisted of 6 books, and like I said, they went into much greater detail into his new theories than the Commentariolus, his initial sketch of his new theories. So it consisted of 6 books. Book 1 established the relationship between the order of the planets and their time periods. Therefore, this indicated that as the farther you get away from the sun, the longer the planets take to revolve around the Earth, indicating that each planet takes a different amount of time to revolve around the sun. Excuse me, I meant sun. And then book 2 elaborated the concepts of book 1. Book 3 was dealt with the perception of the equinoxes and solar theory. Book 4 discussed the moon's motion. Book 5 discussed the planetary longitude, and book 6 discussed the planetary latitude. So Copernicus died on May 24th, 1543, shortly after On the Revolutions was officially published. However, his fame and book spread across Europe during the 50 years following his death. Unfortunately, the heliocentric model did not receive a warm welcome, and if Copernicus was still alive for this reaction, he certainly wouldn't have been surprised. Keep in mind that the Catholic Church and religious beliefs, Christian religious beliefs, were very dominant at the time and ruled scientific thinking and just thinking in general, and science and astronomy was no exception to this. So people felt that it was against the Bible. It implied that his heliocentric model implied that Earth was just another planet, and humans did not occupy the central position of the universe. And to most people, this felt like he was insulting God in a way. So On the Revolutions was actually placed on the Index of Prohibited Books in 1616. However, astronomers could not deny that this served a better explanation to the universe, to why the planets revolved around the Earth and took weird paths, and they saw that there was discrepancies in the Ptolemaic model. So they ended up altering Copernicus' model by leaving the Earth at the center, but they adopted many of his other ideas to try to keep hold the beliefs of the Catholic Church, but still incorporate his new ideas, which were definitely more accurate. So actually, the first known astronomer to fully adopt the Copernican model in its entirety was Michael Maestlin, and he was a professor at the University of Tübingen. I'm sorry, I'm probably butchering that. However, he taught his students that the heliocentric model was superior. And it just so happens that one of his students that he taught this to was Johannes Kepler. And Johannes Kepler actually ended up being a very important leading thinker of the scientific revolution later on, as he built upon Copernicus's model and created a much more accurate description of the solar system. Despite being widely rejected in the first years after publication, people began gradually abandoning the Ptolemaic model and accepting the Copernican model. Copernicus's work is known to many as the beginning of the scientific revolution, as he caused natural philosophers to think and look at the world in a new way, relying more on observation and mathematics. Copernicus's brave efforts truly transformed the study of the natural world and paved the way for other scientists to emerge as additional leading thinkers of the scientific revolution. One of those leading thinkers being Galileo Galilei, which my partner Lizette is now going to talk about. So now that you guys are experts in two of the leading thinkers of the scientific revolution, Copernicus and Galileo, we are going to allow you to become an astronomer yourself and observe the development of the models of the universe throughout time. So first, you are going to draw the Ptolemaic model here, and this is the geocentric model, remember, with the Earth in the center. Then you are going to draw the Copernican model, the heliocentric model with the sun in the center. And then we want you guys to circle the differences between the heliocentric model and the geocentric model. Really notice the changes that Copernican made to the Ptolemaic theory, and remember how significant these were. Then we are going to have you guys draw the current model of our solar system. And we're going to have you guys circle the differences between this and the heliocentric model, the one that Copernican devised. So, and then we're going to ask you a series of questions. So, what additional changes were made to this model? Do you think that there's a possibility that there is a model that has not been created yet that could possibly explain our solar system more thoroughly? If yes, what would this look like? And then we want you guys to draw your possible models of what our solar system could possibly look like, but no one has discovered yet.